A process is unit of work to be completed until it is resolved. In PRPC, in general, what is a process? To achieve some task. How we are going to achieve the task? By performing some steps or the activities. You are going to perform those steps or the activities to complete a work. We can also call it as a unit of work, right? So that's why we can say that in PRPC, a process is a unit of work to be completed until it is resolved. So when we were discussing about the different types of users, like business users, the business managers, then process architect, system architect, then system administrators. What the business users are going to do? They are going to receive the new work. Once the work is received, it should be processed, and finally it's going to be resolved, right? So they need to perform the work or the task until it is resolved. So similar to that, here also in PRPC, a process is unit of work to be completed until it is resolved, right? So in the PRPC, the process is represented using what? The workflows. In PRPC, the process is represented using workflows or flows. To design those workflows, we use MS Visio up to PRPC 6.1 or the process modular from PRPC 6.2, right? So currently we are using the PRPC 6.1, so that we are going to use the MS Visio to design the workflow diagrams. To design the workflow diagram, we use MS Visio. Then what is a flow or the workflow, right? A flow is nothing but a process, or we can also call that flow as workflow. A flow is nothing but a process or the workflow. In PRPC, the flow represents the application's business process. A flow represents the application's business process. In PRPC, a flow also provides the visual representation of an application. Means like we are saying that to design the flow diagrams or the workflow diagrams, we use MS Visio or process modular, right? So what the MS Visio is going to provide? MS Visio is going to provide some specific shapes to design the workflow, right? So that's why here we can say that a flow is visual representation of an application. Visually you can identify what's going to happen, right? So where it is starting, what are the input parameters it is required, what are the conditions it is trying to evaluate, to whom the work is going to be assigned, right? What are the calculations it is being performed, and by looking at that flow diagram we can identify, right? So that's why we can say that a flow is visual representation of an application, right? Like how the application is going to work, then what are the input parameters required by the application, and are there any decisions needs to be taken. In the flowcharts and all, we are going to have some shapes like similar to that. Not exactly same as the flowcharts, but flowcharts are the static. Here the flow diagrams are the workflow diagrams. Those are created by using MS Visio or dynamic. Where it comes to the flowcharts, only static. If you do some changes in the rules, those changes will be automatically reflected in the workflows, right? Next, flow defines how the work objects are created. What is work object? As of now, you can remember that in the previous session also we have the objects that we are going to create for the work types can be called as work objects or not. We have already discussed that, right? The objects that we created for the work classes or for the work types, we can call them as work object. This flow defines how the work objects are created, processed, and finally resolved. Work object means a work is nothing but an object which needs to be created, processed, and resolved. So if you want to process the new work, we need to create the new object. We need to create the new object. So that object we can call it as work object. That object we can call it as work object. So that's why we can say that a flow defines how the work objects are created. Once the flow is created, it is going to be used by the business users, right? Flow is nothing but the process. Process is nothing but an application. So when the user use that application, or when the user run that process, or when the user run that workflow, so if he wants to process some work, then he has to run that workflow, right? So when he runs that workflow, the work objects are going to be created for each and every work, different work object. Then once it is created, it should be processed, and finally it's going to be resolved. Here you need to remember that the flow diagrams are dynamic, they are not static. In PRPC, the flows are also rules. In PRPC, the flows are also rules. Then how to create these flow rules means the rule category is process, and the rule type is flow, and the class is rule-obj-flow, right? The rule category is process. Rule type is flow, and the class is rule-obj-flow, right? Syed, Sagar, and Vidya, you are able to hear, right? Sagar,
Yes, sir. I'm able to hear you, sir.
Syed, okay, Vidya also. Right? Now we'll see how to create the flow. OP11, right? Password is root. I think we have already created some properties here, right? And we have also created the model rules. Right, now in this class itself I am trying to create the flow. Class, select new, what is the rule category? Process, and the rule type is flow, right? Let's say I'm giving it as just, okay. Here applies to class, to which class this flow rule should belongs to, and the type of the flow, nothing but the flow rule name, nothing but the flow rule name. So instead of flow rule name, they have given it as what type of flow you would like to create, right? So the name of the flow should represent the type of the flow you would like to create. Next, rule set and its corresponding version. Here template you can give it as blank, and in the coming sessions we will see what can be specified, or for which flow rules, which type of flow rules we need to specify the value for the template. So but for these flow rules, as of now, we can leave that template input field as blank, right? There are some values for these templates, right? When we need to specify these values that we discuss. Okay, now just click on create. This is the flow rule form. This is flow rule form. There are some tabs like diagram tab, parameters tab, pages and classes tab, design tab, then process tab, use cases, requirements and history. In the diagram tab, it is going to show you the diagram that is designed by you, workflow diagram. As of now, we didn't create the diagram, right? So here in this case, you are going to see the flow diagram that is designed by you. Then using this design tab, you can edit the flow using MS Visio as a separate window. You can edit the flow. So to edit the flow, you can click on edit flow external. Edit flow external, which will edit your flow diagram using MS Visio. See here, as a separate window. Now, one more option here it is. So if you want to edit the flow as an internal window to the PRPC, then click on open. Right. So if you click on that flow editor, it edits the flow diagram using MS Visio, but as an internal window of the PRPC. See here, this one, if you click on this, it also edits your flow diagram as an internal window, which is part of the PRPC. But if you want to edit that flow diagram as in a separate window, then you can click on edit flow external as an external window. Right? That's the difference between these two. Now we'll try to edit the flow diagram as an internal window by clicking on this flow editor. These are all the shapes that can be used to design your workflow. Right? Now we'll discuss. By default, it adds one shape called start shape. The shape is called start shape along with one connector. Right? Now we'll discuss about the shapes. We can call these shapes as smart shapes. Hmm? Now first one is the start shape. First one is the start shape. This is the start shape. The start shape represents the beginning of the flow. The start shape represents the beginning of the flow or task. But here, start shape mainly there are two, you can count two portions, right? Here in the top portion of the start shape, is displaying what? Which class it is? Applies to class. What is the applies to class that we have given in the new instance diagram class? The same applies to class will be showing here in the top portion. Here in the bottom portion, flow type, right? The start shape mainly it's going to have two parts. In the top part, it's going to display the applies to class of the flow rule. In the bottom portion, it is going to display the flow type. Yeah, Sagar.
Sir, there is some disturbance. It may be your white phone wire. No.
Is it clear now? Hello? Sagar.
Okay, sir.
Right. Right? So, in the start shape, two portions. One is in the top portion, it displays the applies to class of the flow rule. And here in the bottom, it displays the flow type. It displays the flow type. The end shape. This one is called end shape. This end shape represents the end of the flow or task, right? ఇది మొత్తం డ్రాయింగ్ కాపీ అయిందా? Why? Okay. Instead of wasting the time for it, I think you should copy, right? Right. The end shape represents the end of the flow or task, right? And the next one is this one. This one is called flow shape. The next one is called flow shape. The flow shape can also be called as sub-process shape. The flow shape can also be called as sub-process shape. What is the use of this flow shape means? The flow shape can be used to call another flow. So the flow shape can be used to call one flow from another flow. Let's say right now we are in which flow? Test flow. Right now we are in test flow. From the test flow, if you want to call the test one flow, then we can use which shape? Sub-process or the flow shape. The flow shape can be used to call another flow or the sub-process. So in the flow diagram, when it reaches this flow shape, the execution control will be transferred to the subflow, right? Then once the subflow's execution is completed, once the subflow's execution is completed, then control will be sent back to the calling flow, right? When you run the flow, when the flow reaches this flow or the subprocess shape, when the flow reaches this flow or the subprocess shape, then the execution of the main flow will be stopped. The execution of the main flow will be in paused status. Execution control will be sent to the flow which is called by this flow, right? Then once that called flow execution is completed, then control will be sent back to the calling flow, right? Here in the flow, what is the main use of this flow as subprocess shape? Can be used, what is the use? Can be used to call another flow. Here mainly we have two types of flows. One is calling flow, another one is called flow, right? When the flow or when the calling flow reach the flow or subprocess shape, then the execution of calling flow will be in which status? Paused status. Stop means complete stop, right? Then execution control will be transferred to the called flow, right? Once the called flow completes its execution, then the execution control will be sent back to calling flow, and execution of the calling flow will be resumed. Will be resumed. This type of processing is called synchronous processing of the flows. Means in the synchronous processing, one flow is going to wait for another flow. Means the calling flow waits for the call flow to complete its processing. That type of processing is called synchronous processing of the flows, right? In the synchronous processing, what will happen? The calling flow waits for the called flow to complete its execution. Right? Okay. So this is about the flow or subprocess shape. Okay. Means you need to remember that what is the main use of the flow or subprocess shape? To call another flow. So when it is trying to call another flow, it follows the synchronous processing of the flows. Means in the synchronous processing, one flow is going to wait for another flow to complete its execution. So we can call those flows as calling flow and called flow. Means the calling flow waits for the call flow to complete its execution. How it is going to execute the two flows or the two process means this is the thing, right? What will happen? If you want, we can make them as some steps, right? The calling flow waits for the call flow. Okay. Next, Sagar, Sayed and Vindhya. You're able to follow, right?
Yes, sir.
Sayed,
Yes, sir.
Vindhya.
Yes, sir. Sir, once show me the start symbol. Start.
Yes,
So,
yes. I think you want to ask what is the difference between these two, right?
yes, yes, yes.
See here. Here you won't observe the much difference. I will show it here in the visual, right? See here. This is the start shape. Here, if you see here, start shape is going to have two lines in the two portions, right?
Yes, yes, sir.
If it is the flow shape, similar to that, there won't be any lines in the portions, right?
Okay.
India, that is the difference
Okay.
between these two.
What are those lines indicate, sir? Any information on them?
Here, these lines indicate the top line, it indicates the applies to class, and the bottom line indicates the flow time,
Okay.
right?
Okay.
Right.
And sir,
Yes,
here in the flow symbol,
right.
do we mention the subflow name or it is empty?
Now we didn't mention anything, right? That's why it is displaying no data, right?
Yes.
If you mention the subflow name, then it is going to display that name, right? Or the rule name. See, let's say you try to mention some rule here. Now see there, right? India,
Yes, sir.
right. So the next here it is enough. The next shape here it is spin off. The next shape here it is the spin off. The spin off shape also works similar to flow shape. The spin off shape also can be used as similar to the flow shape. What is the use of the flow shape? To call another flow. The spin off shape can also be used to call another flow. But the difference here it is, if you are using the spin-off shape to call another flow, then calling flow won't wait for the call flow to complete its execution. Both calling flow and the call flow run in parallel. That type of processing is called asynchronous processing of the flows. That type of processing is called asynchronous processing of the flows. In the asynchronous processing, both called and calling flow are going to run in parallel. One flow means the calling flow won't wait for the call flow to complete its execution. Right? Asynchronous processing of the flows means calling flow won't wait for the call flow to complete its execution. Right? Both calling flow and call flow run in parallel. Right? That is the difference between the flow shape and the spin-off shape. If you use the spin-off shape, it follows the synchronous processing of the flows, means one flow waits for another flow to complete its execution. In the case of asynchronous, both flows are going to run in parallel. Then when we can use the spin-off shape, means to do the parallel or asynchronous processing of the flows, which shape can be used means spin-off shape. There is another shape called split joint shape. Split joint, not giant, okay? Split joint. The next shape is split joint shape. There itself the meaning is there. Split and joint means a flow can be splitted into number of individual flows. The splitted individual flows, all the individual flows, those are splitted, are going to run in parallel. Later on, if you want, you can join them together, or you can end them together, or you can end them separately, or you can join them together. Means if you have a flow, to process it some different processing, you can split them into parallel flows. You can split them into parallel flows. Parallel flows means one flow is not going to have dependency on another flow. All the flows are going to run in parallel. Right? If there is no dependency, if you don't want to have any dependency between the flows, so that main flow can be splitted into number of individual flows, number of more than one or more than two or more than three. A flow can be splitted into number of individual flows at runtime. All those individual flows are going to run in parallel. We can join them together if you require. If it is required, we can join them together and continue its process. Or if you want to end them separately, it also provided by via PC. Means you can also join the splitted individual flows if it is required. Otherwise, we can end them separately or the individually. So here in this case, the split joint shape is also can be used to do the parallel processing of the flows. Which shapes can be used to do the parallel processing of the flows means one is spin off, another one is split joint. Okay, can be used to split if to split the flow into multiple individual flows at runtime at runtime. All those flows run in parallel. Later they can be joined together if required. Okay, this is about the split joint shape. So mainly you need to remember what are all the shapes that we can use to do the parallel processing of the flows means spin off and split joint. Join if it is required. Synchronous only. It's not. I didn't say that it's synchronous, right? All flows are running in parallel means what? In the synchronous, one is going to have a dependency on another. The output of that one flow may be passed as an input to another flow, right? But whereas in the synchronous, there won't be any dependency between those flows, right? Next one is the connector shape. We'll see. Next one is the connector shape. Right? So what is the use of the connector? So the connector shape can be used to connect the two shapes in a flow diagram. Right? But here every smart shape, right? Every smart shape that we are using to design the workflow diagram is associating with its own properties, with its own property panel, with its own property panel. What is the use of that property panel means to reference the rules. Let's see here. Let's say this is what shape? The flow shape. So here the flow rule. These are the properties. See here, sub-process properties, right? Then if I select start shape, start properties. If I select spin-off shape, spin-off properties. If I select this shape, split join properties. If I select this one, connector properties. Okay, like that. But here you need to remember that every smart shape is associating with its own properties, which is used to reference some rules or to specify the values for the attributes. To specify the values for the attributes. That will write it here. Every smart shape associating with the property panel, right, which is used to reference the rules and to specify the values for required parameters, Here, by default, this connector doesn't associate with any properties. By default, a connector doesn't associate with any properties, but the connector is going to associate with different types of properties based on the shape it is associating with. If a connector, let's see here, there is a start shape, right? This start shape is associating with a connector. Are there any properties? No. Like that, if a connector is associating with, which shape is this? That is also start shape, right? Here, see here, different types of properties, right? So by default, a connector doesn't associate with any properties, but the connector behaves differently. The connectors behaves differently and associate with the different properties based on the shape that is associating with, or based on the shape that is connecting with. Right? A connector behaves differently and associating with different properties based on the shape it is connecting with, right? Based on the shape it is connecting with, it's going to associate with different properties and it is going to behave differently. The next one is decision shape. Next one is the decision shape. Next one is the decision shape. We'll discuss about decision shape tomorrow. Tomorrow we'll try to have some. Tomorrow is Friday one, right? Friday. So Saturday we'll try to have some lengthy session. So we need to tomorrow and after tomorrow we'll try to complete all the shapes and we'll try to create our first workflow, right? And we'll also discuss what is work object, right? And how the work object can be created when you run the flow, and what are the default parameters for the work object, ID, status, absence. We'll discuss all those things. And we'll also see the different types of flows. Like starter flows, sub flows, screen flows, straight through process, right? We'll try to complete all these topics at least by Monday or Tuesday. Okay, any questions? Sagar?
No, sir.
Syed?
No, sir, I have none.
Syed? think he won't talk much, right? Vidya?
No, sir. No questions.
Right. Thank you.
Sir,
Yeah, Sagar. Hello?
sir, can you check the installation
Right.
after?
I'll check it right now. Okay?